Hello everyone. In this video we are going to talk about our project that is cast search using a single portrait, and this project is part of the summer internship conducted by Leadingindia.ai at Bennett University, and the project is mentored by Dr. Gaurav Singhal, and the team behind this project is myself, Bhavya Naya from Mar Basilius College of Engineering, Trivandrum.
Sharon John Verghese from St. Kitts College of Engineering.
Anil Chaudhary from SMT Indira Gandhi College of Engineering.
So basically the aim of our project is to localize and identify a person in various environments using a single portrait. We train our data set in such a way that it will be able to find a person. Single portrait means a picture of a person we can use to identify that person in a video or a video frame. Now this concept is used in various applications like in law enforcement, where culprits or criminals, a picture of a culprit can be used to identify them in videos like in surveillance cameras or CCTV footages, where we'll be able to find them and the cameras that are located in various places like streets, buildings, offices. So using that, police will be able to catch them. And another application is our project that is cast search. Over here the actor or actress that we have the picture of, we can use that picture, a single portrait of the picture, to identify them in the movie or movie frames as well. Here, whenever the actor or actress will be having the appearance on the frame, it will be able to detect using the bounding box. And our basic aim is to bridge a single portrait to a set of samples. And the dataset that we are using over here is a cast search in movies. Now this dataset has a total of 64 GB training dataset, 41 GB of validation, and 52 GB of testing. And it also has 128K tracklets, which is having 1218 cast of 192 movies. And the related technologies or approaches that we are using, related work that we are using, is person recognition and person search.
We go with the following step. First, identification of faces, analyzing of faces, face encoding, finding person identity. For identification of faces, we are using histogram-oriented gradient hog, which was invented in 2005. By looking at each pixel, we will make an arrow showing the lightest pixel to the darkest. This conversion of pixel into array form is called as gradient. In this manner, the entire image turned into the form of arrow by breaking the image into small square of 16 by 16 pixel each and taking the arrow direction that was strongest. Final image is known as hog image. By comparing it with the face hog pattern, we can easily detect the faces in any image. Second, analyzing the faces. Once we detected the face in an image, now we have to deal with faces which turn different direction, look different to the computer. To overcome this problem, we are using face landmark estimation, which has 68 specific point landmark to check the images. Third one is finding the special and various features from the face. We will use CNN model with triplet loss function, which will generate 128 measurement of each face. This 128 measurement is known as embedding. The process of training a CNN model to output the 128 measurement will require a huge amount of time and computational power. Therefore, we are using the pre-trained model, which will run over every image to find out 128 measurement of that faces. Fourth one, person identification. This is very easy. We just have to check the known person who has closest measurement to our test image. This is a classification, so we can use any classifier. Now we are using SVM, support vector machine, and KNN classifier. In our case, the test image will be the frame of movie and known image is a cast image. We will encode the cast image and iterate with all the test images and save the closest match measurement as an output. So what we achieve is that we will give a cast as an input and its related candidate, that is a frame of movies. So the output will be all the frame in which that input cast will appear.
In this project, we went through a new problem called person search with one portrait. It is very challenging yet very useful and is a must in real world applications. Such projects will help a lot in the future, and approaching such projects will reduce the human effort up to a very great extent. Some of the limitations what we found while doing our project was that data processing and storage has limit on facial recognition. That means high videos, even with high resolutions, often seems quite in low resolution when compared to digital images, and their storage can be also occupy significant amount of disk space. Another limitation is that face recognition has low accuracy when compared to other proven performances. Now, facial expressions, aging, and other factors are also causes some difficulty in identifying the faces. False accept and false reject are some of the other limitations. That means it may accept or reject false faces which should not have been accepted or rejected respectively.